We are beginning number 4 on chapter 3, section 4, dealing with linear programming. I'll write that right here. All right, and what we're going to do is we are going to do the graph of x is less than or equal to 0 in blue, y is less than or equal to 0 in red, and finally 4x plus y is greater than or equal to -7 in this magenta color. We're going to graph these three inequalities. All right, just remember, where x is less than or equal to 0, that's going to be your vertical line, so I'm going to write vertical. Where y is less than or equal to 0, that's going to be a horizontal line. Okay? And x is always equal to 0 where? It's always equal to 0 on which axis? The y-axis. Alright? And if we were to shade everything that's less than that, we shade everything to the left, but I'm going to kind of wait to do that. Alright? We'll kind of understand why, but I wouldn't take all of your pencils right now and start shading because it's just going to get really, really, really dark. But I'll go ahead and I can do mine, but on your paper I would just leave it blank for right now. Okay? So you don't get it too overshaded. Alright, y is less than or equal to 0 is right here on the x-axis. And you'll notice that everything right here below that will be shaded. So right now you can clearly see where the solution region or the feasible region is. Which quadrant would we be in if I said, what is the solution to those two? We'd be in the third quadrant right here. This would be our answer. Okay? Now the last one is not in slope-intercept form. Okay? So we're going to change this to y is greater than or equal to mx plus b form. Now Jacob, whenever you see a plus in front of the y, that lets me know that this sign right here is not going to change. It's going to stay the same. So you can always be confident that if you see a plus, it could be a 3y, it could be a 4y, it could be a 7y. If it's plus, you know that inequality is not going to change. So right here, we only have to do one thing with this 4x. What do we have to do with this, Ariel? What do we got to do? Take that 4x and do what with it? Move it over. So if we move it over, we move this and say, you know what, I'm just going to throw you across that greater than or equal to sign. What's going to happen to it? That's right. It's going to become negative 4x. And what's already over there? A. That's right. So now we have our slope, which is a negative 4, which is the same as negative 4 over 1. And we have a y-intercept at negative 7. Now some of you watching this video might not be comfortable with what I did. And I totally get it. If you had 4x plus y is greater than or equal to negative 7, some of you might be saying, you should have added its inverse to both sides. Well, you're right, you could have added its additive inverse to both sides to zero it out, but you still get the same answer. Okay, so if you like subtracting 4x or calling it additive inverse, that's fine. But either way, you get the same thing. Just remember, whenever you move a number across an inequality or equal sign, it just becomes the opposite of what it is. So, when we're graphing this, where are we going to start? We're going to start at the negative 7. We're going to put a point right here at negative 7. 1, 2, 3, 4, 5, 6, 7. Put a big old point right there. That's my y-intercept. We're going to go down 4 units and over 1 to the right. Oh no, I can't go down 4. I can go up 4. 1, 2, 3, 4, and over 1 to the left. Up 1, 1, 2, 3, 4, and over 1 to the left. Now this one I'm actually going to make a little bit thinner of a line. All right, so I'm going to connect this right here. There's our line. And where are we going to shade? Everywhere greater than or equal to that. And you'll notice that when I do that, there is one area that's just slightly darker than all the rest. But hopefully you'll understand why I decided to say, don't do it once. Kind of wait to the very end. Okay? Can everybody see that this right here is the solution region right there? So what I'm going to do is I'm going to go back and quickly graph it so you guys can clearly see what I'm talking about. All right? So once again, we're going to have the vertical, the horizontal, and then we had a line right here at negative 1, 2, 3, 4, 5, 6, 7. We went up 4 and over 1 to the left. We drew our line in purple, going through that point right there. And our solution region, everybody, is right in here. So there's our solution region. I'm going to put 3 orange dots. I'm going to put a dot right here, a dot right here, and a dot right here. Those are our vertices. So how many vertices do we have to worry about? We have to worry about 3. I'm going to put ordered pair, ordered pair, ordered pair. Now, this vertice right here is easy. That's at 0, 0. This vertice right here is another easy one. That's at 0, negative 7. This one is where it gets a little bit trickier. All right? So right now, we have a red line intersecting with the what? With our magenta. So we have a magenta line and we have a red line. Our red line is y is equal to 0. I know it says less than or equal to 0. We're just going to graph y equals 0. Our magenta was y equals negative 4x minus 7. Now, if we wanted to do this algebraically to figure out what's the x value and the y value, we already know what the y value is. We already know the y value is equal to 0. You can clearly see that. Our y value is equal to 0. Well, how would we solve for our x value? Well, what we're going to do is we're going to use substitution. What is y equal to? Y is equal to a 0. So what am I going to do? Y equals 0. 0 equals negative 4x minus 7. And now what am I going to solve for? I'm just going to solve for x. I'm going to add a 7. I get 7 equals negative 4x. Divide each side by negative 4. X equals negative 7 fourths. So we're left with negative 7 fourths and a 0. Now that's what you could do if you wanted to solve it by hand. But if you wanted to use the graphing calculator, you guys can actually type these into the graphing calculators and find the point of intersection. So we're going to do that real quick, okay? I'm going to go y equals, I'm going to clear this out. I'm going to hit y equals 0 and y equals negative 4x minus 7. I'm going to hit graph. There's my first graph, there's my second graph. All right, and here are the steps to remember how to find the point of intersection. You guys remember? Second, trace. Number 5, and press enter 3 times. 1, 2, 3. There it is. Which is that, by the way, same thing. So if you guys see this right here in your calculator, like, well, you said it was negative 7 fourths. That is the decimal equivalent of negative 7 fourths. Okay? That's how you can find a point of what? Point of intersection. Okay? Now let's go back to our paper. Here's our function, everybody. Here's our function. What are we going to do with this function? We're going to plug in all of those vertices into this function. So scroll down with me and we'll do negative x minus 4y. Here we go. So we have f of x comma y equals negative x minus 4y. And you'll notice I'm going to open up not 1, not 2, but 3 sets of, don't think of hard work as a punishment. Just think of it as a way to get things done correctly. What are my ordered pairs? 0, 0. We've got a 0, negative 7. And we have a negative 7 fourths 0. All right? So we're going to plug those in, press enter, and we're going to get this answer, we're going to get this answer, and this answer. And then we'll determine whether something is a maximum or a minimum. All right? So, right here, what does this first one evaluate to right here? We've got a 0 minus a 4 times a 0. That gives me a whole lot of nothing. Here I've got a 0. Oh, negative times negative is a positive. That's a 28. Here that becomes a positive minus a 0, so that's just 7. So now you look at 0, 28, 7/4, and you ask yourself, self, what's the minimum? The minimum would be a 0. What's our maximum? Our maximum was a 28. That is the final part of your answer. So what am I expecting to find on your paper? I'm expecting to find an accurate graph of where the feasible region, basically your solution region, is. Okay? I'm expecting you to locate where the vertices are located. 2 of them were easy to find. The other one, you actually had to figure out where was that point of intersection. And we did one by hand, and we did one using the graphing calculator. And that's it. We're going to go do problem number